Mm-hmm. All right. I've got a presentation up on stream. Welcome. I am Dr. D. Kyle. Chat says they cannot hear you, Kyle.
This is dropped to default. There we go. There we go. USB mic is working now. I don't know why it's having the same issues it says it is, but USB mic is working now. Okay. So we'll do some editing before we do the final upload of this, but we'll get the first live stream running. So should be working now. It looked like it was getting the audio in the stream, but now that will be in all of the other things. So we'll jump.
Sorry, I got really excited that we actually had a viewer for a second.
Right. Let's just start there and enjoy it while we can, right? So there's a couple other things. I'm also going to add in a compressor real quick, which I should have had initially, but that way if I get too excited, it'll clamp down a little bit on my end of the audio. So we should be okay there, and the stream looks like it's healthy. So we'll go back to the first one here real quick. So welcome everyone. We'll edit that first part out in post. No big deal. Part of the fun of doing podcasts and all this fun stuff on the fly, but we have a pretty entertaining collection of things for you today. So I'm Dr. Staggs.
I'm Dr. D.
And what we're going to do as Paradox today is we're going to talk about the elephant in the room. With all this virusy stuff going around, we thought the flat earth would probably be a pretty important thing to cover. So there's also some things, if we have some time, we'll get into some of the scripture involved in this, but we wanted to first touch on some of kind of the older ideas and some of the models for what has been presented for the flat earth in order to give some sort of a context for what people believe, because I want to be very clear that we're not looking to we're not in this business here to focus on being in a position where we see a lot of negativity and things, calling people idiots and all these sort of ad hominem attacks and things at flat earthers, and calling them all sorts of names, all sorts of things, and trying to, there's all these issues with them being made fun of and sort of all of these other bits and pieces involved. But we want to actually have a conversation about this. And so I can't wait to see what happens in the comment section and things in the video afterwards, because I'm sure there'll be at least one or two people that have some sort of an opinion on this topic. And so I'm sure we'll be told why our opinions are wrong.
Sure. And you know what? I'll direct you to some of my students. Dr. D, it's an opinion. It can't be wrong, right?
Right. Right?
Mm,
Well, there's some interesting things that are proposed in some of these models, and there's
yes,
some ideas,
certainly.
particularly this older map on the far right of the square and stationary Earth, because this was taken. I call this the OG snack dish model, because this is one that's much older, but it looks just perfect for sort of holding your Cheetos as you're trolling on the internet, which is probably what most of the people commenting are going to be doing. So some of where this came from
Nothing
is
wrong with Cheetos.
trying to reconcile the some of the scriptures that speak specifically to a lot of the topics, including the four, coming from the four corners of the earth. And there's actually a lot more scriptural content than I thought, because I did a bunch of researching on this earlier today. So we'll see if we have much time to get into that. This is probably a large enough topic that we're going to have to get into multiple of these discussions. But here on the left, we see a simple version of circular diffusion. This is not one of the core total beliefs in this system, but this is one of the proposed model. You also see the Arctic ice wall. There's lots of things to talk about in regards to that. But
So, and also they have tabletop models set up,
yes,
like the one here on the left, right? So you can actually buy them. They're actually, regardless of your belief, they are really nicely made.
they are
very highly.
They are.
Craftsmen.
The craftsmanship
right?
is rather incredible, actually.
Yeah, they're really nice.
Someone has taken a great deal of time. Some of the other things that are on the screen at the moment are just presenting examples of what have also been discussed in terms of some of the models of trying to take scripture literally and doing a lot of things kind of badly, but talking about the waters above and the firmament and the deep and all of those things that are not things that we're going to spend a lot of time getting into, because there's a lot of room for interpretation and a lot of things that are discussed there that we'll talk about some of the differences between poetic language and literal language. So there are a couple other things that I thought would be good starting points to discuss, and I'm curious to hear especially some of the factors that you've come up with in your research, just to see, including things like this model here on the left, which is less of a circular sort of illumination and a little closer to what we actually observe on Earth, with the exception that basically parts of Russia and parts of Alaska and northern Canada are under sunlight basically 24/7 in this particular model.
Yeah, we know that that's not true for most of the year. There's actually large portions of the year where they have no light at all, right? So
yeah. But they solved this, of course, with the pictures in the center, where it goes back to the infinity tropic to tropic back and forth theory, right. And so
infinity plan.
It's really, really interesting. And so it talks about where the sun is, and so the sun does rotations inside this rotation. So the sun is doing this really odd pirouette thing. It's strange. It's not like even gyroscopic precession. It's just interesting.
Some of this theory, right, is that there are multiple of these disks, right, that are outside of, like, so the disk that we are on is not the only disk, right? There's another disk Earth, like, outside of that, and then we don't know about that because we can't possibly get past this
the great ice wall, right?
This Game of Thrones ice wall, right?
That makes that winter is coming thing actually sort of have some credibility. So maybe they were in on it the whole time. I don't know.
Maybe George R.R. Martin is actually a flat earther.
Or maybe he's one of the people that came from the kingdoms that took all the Israelites out to the ice wall. I'm getting ahead of us here. We'll get there. Don't worry about it. So we will be talking about some of those things, but I wanted to quickly touch on some of the problems with the lighting here. So on the far left, one of the things to really pay attention to is this idea that the light is like non-uniformly being distributed here, which is really, really bizarre. And one of the things that is really, really, really important to flat earthers, above and beyond really anything else at all, is this idea that we want you to prove it. We want you to do experiments, not just do whatever the internet says, right? And that's one of the things that I find so interesting. So I brought with me a laser source because we like coherent light for doing experiments, right? So
Sure,
you got to
sure.
see in the documentary there what they did. And so talk a little bit real quick before I do this experiment to discuss light and diffusivity of light and things like that. What did you note about their particular experiments with the lasers? Because I found those to be quite
So
humorous.
so there so what Dr. Sags is referring to is the documentary Behind the Curve on Netflix,
It's epic.
which I recently watched today. So it's very fresh in my mind. And so they've ran two experiments of note in this documentary. The first being they didn't run it on the documentary, but they discussed it. Is they had a laser gyroscope, okay, and they went through the math, and from the math, if we are in fact rotating, the gyroscope would have about 15 degrees of tilt to it, right?
Hmm.
If the Earth is rotating, there should be about 15 degrees of tilt on the gyroscope. So they purchased this green laser gyroscope, which is
Hmm.
perhaps the most precise gyroscope that is out there right now.
Yeah.
That's
What
not
was it,
being
like
experimentally developed.
75 grand or something like that?
They said the number they said was it was 20 grand just for the gyroscope.
Okay. I remember the
Um,
whole thing being like
yeah,
outlandishly expensive.
the
Like
entirety of all of their experiments was approaching somewhere in the ballpark of 50 to 75 grand,
maybe
somewhere in
that's what
there.
I'm remembering. Somewhere in that ballpark. So the considerable capital has been put
Yeah.
into this, and so that's why we're taking this seriously, not sitting around going, "Oh, you people aren't scientists. You're just a bunch of morons," right?
No.
We're
But
actually
that's not what we're saying. They have some very sound experimental methods. It's not like they came up with a problem statement, right? They
hmm
used the scientific method appropriately.
hmm
And um the experiment found that when they had their gyroscope that there was about 15 degrees of shift, right? And so it disproved, for lack of a better way of saying it, right, disproved the fact that their hypothesis was that there would be no lag, right, and
right.
no tilt, and you therefore the earth is not spinning but moving in this straight, just moving upward,
Right.
right.
Right. Yeah. I
um
think the laser experiment for distance was one of my favorites because
mhm.
they're shining a laser and they're talking about, well, if the Earth is flat like the surface of this like this surface, right, then it's just going to go on and on and on and on and on. The some of the problems that we have with light fundamentally, and this even comes back around to that model that we were looking at, this idea that the light is going to stay perfectly collimated and aligned and all those things. Now the optics in this little Chinese toy are terrible, but it's shaped like Darth Vader's lightsaber, so that lends it a little more credibility. I
Sure.
have to cut it a
Which
little slack,
makes
right?
it better. It gives it more power, actually.
So it does a little bit. And so what you'll notice is this is a circular beam, and you can actually see that lighting up on camera pretty well. It's a little hard to aim and maintain this on camera, but the idea is it becomes a little bit more diffuse, and I can't really reach far enough apart for that to become as big of an issue. But depending on the quality of the optics of that laser, because I'm one of the only people that I know that was actually government certified to align and operate open class 4 laser systems, which is really the really fun kind, but that's the dangerous kind that, like, if you reflects off your badge, you can cut somebody in half kind of thing. It's really, really bad. Anyway, those are
Mhm.
that diffusion process of light is radial, and one of the problems with some of these models are trying to explain in just the sense of lighting, for instance, the idea that the light only is allowed to go into this, is allowed to go a different distance from the center than it is all the way out to kind of the edges of the earth, so that half of the globe is illuminated all the time from where that fake sun is, right? That's so why is the light stopping at different distances all along this sort of invisible dotted line about halfway across the flat Earth model? Because I'm trying to look at it from a standpoint of physics, independent of globe, no globe, flat Earth, round Earth, globe Earth, cube Earth, whatever. The physics is the light you can see demonstrably diffuses in a linear and often conical sort of pattern, and so they're right in saying that it falls off as a function of, I believe it's the square of the distance. It's the inverse square law, right? And so you have this decay of the number of total lumens that are being provided, the number of photons that are actually hitting per surface area, and all these things. Lasers are a lot better at keeping that light collimated over a longer distance, but there's still some diffusion. And that's exactly what they saw with those particular experiments. And I don't happen to have it with me, which would be a perfect prop. But I have one of the exact kind of lasers that they used in those experiments, so I actually know what I'm talking about, because we're like not supposed to have those or something. The point is they stay very highly collimated for a very long distance, and one of the things that I found most interesting about that experiment is they kept talking about how they were confused at the fact that they had to keep aiming the laser up. Right? Did you catch that in the documentary?
Yeah, they were having issues with getting it aligned, right? Because the first experiment that they wanted to run, which didn't work out very well, not because of the results, right, but because they, I don't want to say this, because the laser column diffused too much on them, right? They couldn't get it a tight beam that far away.
Right.
Was when the original thought was, we're going to put up these two towers, right?
Mm-hmm.
And we're going to shine the laser from one all the way to the other. And I forget the distance in between, but it was a decent amount of distance. And I know these aren't, trying to align these by looking at the camera is not a good idea.
Right.
Okay?
Yeah.
And so we've got these two columns. One's going to shoot a laser at the other, and we're going to make sure that they hit at the same vertical height. Okay.
Yeah.
So the example they used was 8 feet.
Yeah.
And so then they're going to put a post in the middle, and the one in the middle, if the Earth has no curvature, the one in the middle will have a mark on it that's 8 feet. Right. Yeah. If there is a curvature in the Earth, then it's going to be less than 8 feet. I think they said about 5-ish something feet. Right. 5.5. That's the number that's sticking in my head. I could be, again, I realize that I just watched this today, and I probably should remember that number.
Should remember some of the numbers, yeah.
I don't really recall that. So anyway, their light column couldn't diffuse, but the issue that they were running into, which was the aiming, right? And so another way of thinking about this experiment, right, is a laser is going to run in a straight line. Right? That's how it works, right? You point it and it goes in a straight line. If I start it at a point that's 8 feet above the ground, you don't even need the middle column, right? Because if it drops, or it would actually be higher, right, on the other side. Right.
Depending on what your frame of reference is. If you start at a point here and you're trying to measure a point over here on the curve, right? You're as a straight line. The thing that I often see as a depiction is they sort of put the source here in diagrams, then they show the Earth curving up and around in between them and the object. That's not actually a fair representation at all of a globe model. So I want to make a clarification there that the Earth doesn't sort of like come up and out in front of me in a curve. The point is because of changes in elevation, which are very important in the context of this discussion, because whether the Earth is flat or curved, there is still a concept called elevation, right? And so height plays a big difference in this and needs to be accounted for properly.
and I'm gonna do something here, right? So the other thing, right, that their model doesn't take into account, you'll have to excuse me for a second while I draw this, right? But their model assumes that what is the case, right? That this Earth is perfectly, right? The globe model looks something like this, right?
Yeah.
That's what it assumes. However, in reality, right, the surface of the Earth
Is not quite.
would look something like this, right? There's peaks, there's valleys, right? I realize this is a very crude
Right.
representation.
It's exaggerated,
right?
but yes, the
But
point
that's the point, right?
right.
And so
Nobody believes that the Earth is a perfect sphere. I think that is a fallacious and cheeky claim. It is spherical, spheroidal. Those are appropriate terms. A perfect sphere, only an ignoramus would believe that. Truthfully. And I think Jason from Engineering Explained probably did the best parody on why that is. It's all because Americans love balls in sports. So, yeah, there's all kinds of things. But when we think about those kinds of experiments, what they're saying is, because of the curvature of the Earth, eventually I should stop seeing a thing. And we do eventually stop seeing things, and so there's a difference between I can no longer focus on it with the naked eye and I can get high-powered optics and zoom in, but at some point the ship that continues to sail away from you eventually disappears.
right.
And that's the problem, is you can't just go with higher grade optics at the same exact height and continue to zoom in forever, because if that were the case, then we would have the ability with the telescopes that can see a gazillion galaxies away. We could turn that sucker around and aim it across the horizon and literally see all the way into the ice wall, because that's nowhere near as far away, right?
Well, I mean, the other thing that you have to take into account, right, is even the ancient Greeks knew that you would see the top of the lighthouse before you saw the base when you were coming into harbor, right? Or if you're in the harbor, you would see the sail of the ship,
Right.
right,
Right.
before you saw the base of this ship, right? And so there has to be some curvature, right?
Yeah,
There
there
has to be.
absolutely has to be. And that's I think one of the biggest challenges. So that's part of the reason why I went ahead and pulled these examples together, is I wanted to be able to show just quickly what these differences look like, because there's this number that's being thrown around that I've found in the research that I've been doing, this 8 inches per square mile. It keeps getting misrepresented as 8 inches per mile, but it's per square mile. That doesn't have the same meaning as it would if it were 8 inches per mile. And you can't just throw out a squared dimension because it's inconvenient for you. Like, that's
Got a lot of students that try to do that. And,
yes, and
never really works out well for them.
Right. It also means that they can't measure and corroborate the data with the actual observations that they're making, and that's the important thing to point out here. Is we're talking about the difference between this idea that comes from hyperbolic modeling of trajectories of things, and this idea that something following a curved path is going to follow this y equals x squared paradigm that is a fundamental equation for a parabola. And I don't have all of the other factors involved there that can be adjustments for all different sorts of conditions, fitting constants and slopes and so on. But the point is, there are these fundamental equations that are being used. The one that is actually more representative is this radius times 1 minus the cosine of the angle. And what does that actually mean? And that's where this comes in. This idea that, and this is not what I'm trying to represent as the be all end all of these these representations, but the point is, if there is a curvature, any point at the surface of the Earth, we can take a look at what this height is because of the trigonometry that we understand. And they love to go back to Pythagoras, and Pythagoras never believed the Earth was a sphere and all these other things. And so I think there's a whole bunch of mischaracterization that's happened here. But this, I think, very, very importantly, we need to understand what the difference in that angle means. And so the cosine of A, this angle, allows us to look at a couple different things, including the height. And we can go through the process of deriving this over and over and over and over. So when we're looking at these kinds of processes, there's a lot of examples that we can work on of trying to actually calculate the data using this formula. Something that is a distance on the horizon. So a distance in flat earther terms, this would be just your distance, how far something away is. For us, the math is a little more complicated because we don't have a non-existent unit system to actually measure the scale of what our model looks like, right? We have to use
just
trigonometry.
Let's notice too, also, right, that distance d, if that is a straight line point to point, right?
Right.
Is significantly larger, right, than the curve.
Yeah.
Right. And so the sheer dimensions of the disk model, right, the sheer dimensions of the Earth, given what we know, right, about how big, what the diameter of the globe model is, right, the sheer distance that they would need for their model to be correct is quite a bit larger, right, than.
Yes, and that's where that 8 inches per square mile thing becomes problematic, because I saw somebody putting together some of the math on that, and it, instead of, for instance, because there's a lot of discussions about, oh well, we see things that are 50 miles and 65 miles away according to Google and all this stuff. And so what we're saying is this should be this really crazy distance down, and so we're not seeing that as a result, because I shouldn't be able to see 50 miles because an elevation difference of 1,600 feet isn't reasonable. And one of the things that is not discussed in any of the things that I have seen, and that's where I think I want to really focus in for a second, is I have not seen a fair representation in that conversation about how does the differences in elevation that we know between those two different points come into play. Because if you're saying, well, this is 50 some miles away, is that at exactly the same elevation, or could it be that is actually separated? You're looking at buildings that are say several hundred feet tall, but those buildings are at a base elevation that is higher by 1,000 feet. Can you go up 1,000 feet in 50 miles? Yeah, there's a lot of places on Earth where that's the case. So you also are not taking some of those factors into account. And so when you're taking reference images and talking about, images out over water, especially, you have no land or frame of reference to tell based on some sort of an estimate for how large a pebble or a grain of sand is. You have no estimate to tell you how high off the ground are you, and a lot of things like that, right? So if your only reference in the photo is water or your scale, that's not meaningful, because how big is a wave? I can't tell you how big a wave is, right? Because it's going to depend on lots of factors, including the fact that waves, as we understand them right now, go actually much farther down into the ocean than just what you see on top, right? There's a
Right.
whole lot of fluid motion that happens underneath to create what you see on top as the wave. So there's a lot more going on than just what you see on the surface. And I feel like a lot of the flat earthers would go, yeah, that's what we mean.
Sure.
Okay.
Sure.
But are you
Um,
taking into account, especially these kinds of elevation differences from point to point, right? Because I know
let
of
me ask you. Let
a
me frame this with another example. Right? Did Bilbo take into account elevation differences when they were stuck in the dark forest in The Hobbit?
there's yeah, there's I think a lot of examples where you there's differences in elevation can make a tremendous difference. And
I mean, yeah.
having lived at 7,000 feet elevation, which I I don't know of a lot of people, especially the folks from like different parts of California and coastal areas that seem to be really enthusiastic, genuinely enthusiastic about this topic. I don't know that they have spent a lot of time at something like 7,000 foot elevation, because
Right.
that's fairly high up there. And I
Yeah.
can tell you that, yeah, you can see a lot, but you can't see the Antarctic ice wall.
Right. Well, so
That's
I think that part
no,
of
no
the
matter how powerful your optics are. Well, if that's atmospheric distortion or magnetism or this what was it, I think I saw one of the Glowbusters things that I was watching talking about incoherent magnetism. So this idea that a bunch of misaligned poles together in a big mass somehow explains gravity, and we don't need gravity, it's just all magnetism.
okay. Um,
Interesting.
yeah.
At least
Uh,
that's a force, which is
sure.
different from the claims that, well, gravity is caused by like buoyancy and stuff.
Yes, that's
Well,
true.
buoyancy is
Um,
not a force. It doesn't have a direction and a magnitude, and it's not a kind of acceleration, and the units are all completely wrong, and so that's not actually a thing. Because buoyancy buoyancy can create a force, but
yes.
it itself is not a force.
Okay. Yeah.
But
Um,
the force is actually being generated by the thing that it's buoyant in, the fluid. The fluid
mhm,
exerts the force, not the object with the buoyancy, and that's also an
right.
important thing to understand.
And it's basically a hydrostatic pressure,
Yeah,
really.
it's a
That's what it
pressure
is.
because of the surface area, and that's how you get back around to the units of a force.
Hmm.
Yes. Yeah. So all these factors are important.
Um, so, I mean, with this, I think that, and we talked a little bit about this prior to the show, right? Is they really don't talk a lot about verticality at all, right? And this is the whole point that you're
That's
making, right?
yeah.
It's a very much a two-dimensional theory, from what I've heard, at least, right? And
Right.
from my research, very
Right.
few people, if at all, I haven't seen anything that alludes to, you know, extra dimensionality, meaning height, right? We're always talking about X, Y, but nobody's talking about Z.
Right.
Um,
Right. And we learned from Star Trek why that's
mhm.
such a terrible idea.
Yes,
I'm literally checking the
Wrath of
Globebusters.
Khan, if anybody is
Right.
wondering.
Yeah. I'm literally checking there's a few folks out there who are in this, and I'm looking in their total video playlist, and I went through a few of them as an example just to get a sense of where they're coming from, and trying to get a sense of what are some of the actual claims that are being put forward by these, so that I understand kind of is what is being proposed, what is being discussed. And some of the most interesting things are like the topics about the photography and things, and their points about, well, a bunch of the NASA images of the globe and things are composited from other things, and so why are they putting out all of these photos that are doctored and they're just lies?
Yeah. Yeah.
That's a valid question.
Sure.
And if you're presenting something that is a rendered something from data and saying, oh, this is an image of the Earth taken with a camera, all right, you have a valid point there. That is not a picture of Earth, and the marble image of 1972 or whatever is one of the number one favorites. So, and it seems like this goes hand in hand. We talked about this just before the show. It seems just hand in hand. There's this idea that you also have to believe that the moon landing was a hoax and all this other stuff. And so there's a bunch of discussions about these things and about the counter evidence and all this other stuff. And I have family members who worked on pieces of things for the lunar landers and pieces of parts for shielding in the nuclear reactors that are running satellites and all kinds of other stuff. And so there's actual real hardware actually floating around in space that real people actually designed and shot on rockets. That stuff isn't faked. Like, there's actual space junk and garbage and debris, and there's a space station out there, and none of that stuff is actually a hoax, because there's actual hardware and all sorts of things. You can see some of these things with the right kinds of telescope settings and stuff. There's examples of, we have this laser reflector on the moon that we're using for experiments, and we can use it to figure out exactly how far away the moon is. And so unless there's just some magical shiny spot on the moon, that's an actual thing that has to be considered. So if there weren't actual people on the moon, how can we shine a laser out into the starlight and then get that same exact laser at the same frequency with the same phase and all those other things, getting that bounced back to us with a time delay?
The answer would be that all of those results are falsified, in fact, right?
Right, but you can find the coordinates of this stuff yourself to aim it at the moon. And all this stuff is publicly available to the people that are willing to look, right? So I think they're asking good questions and being skeptics in a good way, but doing so in a way that's not necessarily being of benefit to all of humanity. Because I think there are some things that are difficult. So those are some of the things that we need to pay attention to. There's some claims that are worth at least investigating with some of these. And so there are some of those. So we talked about the density thing and some of the hyperbolic math. I'm reading my notes from, I don't know, the Koch Foundation or whoever it is that I'm supposed to be answering to, obviously, right? These carefully handwritten notes that they're standing off screen and dictating to me, whispering through the internet into my headphones.
We're just both CIA operatives. Right? So
really, that's what we've done here is we're just trying to figure out how to make it look really authentic and
show you
homemade.
Guys what I'm really broadcasting.
Right, you're not broadcasting from the third cube of Earth. There you go. Right, this is a secret underground military base.
This is my CIA bunker.
Right, that's why there's no furniture in it, is because you sleep on the cold concrete, because that reminds you that you have to keep up the lie, otherwise they'll punish your family.
There's a desk and a computer, and I have to hit a button every so often to make sure.
Right,
that,
just to make sure that otherwise they send the nukes.
Exactly.
So some of the other things that are interesting are the topics like water doesn't curve and it finds its own level. Especially an interesting idea in the context of some of these models. If I switch back over so that you can see them, some of these particular models, if it'll actually display properly. Here we go. So some of these actual models. So here's some of the things that we need to be able to understand is when they're talking about the oceans will find their own level, especially on the one far on the right side there, this sort of old snack dish style model. We're talking about
like a crossfire arena.
Right, it's interesting. So there's a number of countries there that if gravity were a thing in the half donut snack tray model of Earth here, what we would find is that the water finding its own level would mean Australia is seriously in trouble, and frankly, so is most of Africa there, at least the northern parts. Russia's fairly safe, but that would mean that gravity, trying to explain gravity in that context would be very, very difficult. The one in the sort of literal interpretation of the Hebrew language there in a bunch of the Old Testament in the center one is also pretty thoroughly entertaining, but things that we need to keep in mind. So there's a lot of aspects of how these are actually calculated and understood. One of the other things that are interesting there are things like the bubble on a level or something, right? The water around the air bubble in a level is curved, right? They're not
that's how the bubble gets made.
Square. So, yeah. Bubbles aren't square. There's a lot of math behind that, and it has to do with minimizing the surface energy by maximizing the balance between the surface tension and the pressure of the inside of the bubble of that gas. If you were to vigorously shake a bubble level, I don't know why you would want to do that, but you could temporarily, because there really aren't surfactants in there.
It's like an Etch-a-Sketch, right? You have to shake it to clear it.
Yeah. There's so many different things. We have neighbors breaking into their own cars because I'm not in the underground CIA bunker right now, which is a mistake. I should be broadcasting from there, because there I can wear my tinfoil hat safely, right? That's the important thing. So there's also some topics about, well, we can't have an atmosphere next to a vacuum. That was another one that I found very, very interesting. So they're talking about, well, there's this vacuum and then there's this atmosphere. And so how does that work?
How does your vacuum cleaner work?
Differently than the vacuum of space, because vacuum cleaners, this is a really hard thing for people to understand, because they're going to try experiments and they're going to say, see, the vacuum sucks your hand in. But the reality is the vacuums don't actually suck. That's not a thing at all. The vacuums are the vacuums are a difference
that there is
in
a difference in pressure.
Yeah, it's almost like we planned this before the show. The difference in pressure has to do with the airspeed velocities. No, not the airspeed velocities of an unladen swallow. And it doesn't really matter if it's African or European, because that would be an entertaining conversation. But I actually don't know off the top of my head much about African or European swallows, but that's probably because I'm not a king. So some of the things that we do need to consider are that the flowing velocity at very high speed, because of the Bernoulli principle, we understand that high speed means those molecules physically don't have much time to interact with their surroundings, and so they don't have nearly as many surface collisions. As a result of that creates the low pressure condition that we understand as a vacuum. That principle doesn't depend on whether the Earth is flat or a globe, but what that does tell us is that when molecules have less and less and less interaction with each other and their surroundings, then we get into a state of lower pressure, i.e. a vacuum. And so what the Earth does as you go farther and farther and farther and farther away is there are fewer and fewer and fewer molecules, because we still have to have gravity in both of these models, right? And I haven't really seen good explanations about how the gravitational model works in the flat Earth models. I haven't
Gravity
seen
is really
scales
where.
on these maps, and so there's tremendous development work that actually needs to be done in order to develop this as a scientific theory. So the question is, do the people that are looking at this want to develop it as a formal scientific theory, or do they just want to try and stir up controversy and discussion? And so that's where some of the issues that I have with it are. I would like to see this actually tested in the same sort of scientific manner as most of the other crazy ideas in history, like the whole globe thing, like gravity, like the Bernoulli principle, like the idea that we could sterilize things by boiling the ever-loving crap out of them, right? There's all of these things that we could study, but we do that in a scientific manner by saying, well, we sort of have an idea what could happen under these controlled conditions, and we rely on this idea of induction, this principle of induction that says we can test these things because we believe that there's some laws that make the universe behave in such a way that we can expect from one day to the next that if we do the same experiment, we should be able to see analogous results because the universe hasn't suddenly decided that it's going to be a different thing than it was yesterday. So that's the good news, is we can actually make tests and do things like that. So even if you have a flat Earth worldview, then you still have to reconcile the principle of induction that you're going to rely on to interpret your tests, which necessitates some common underlying laws to the universe that would have to behave the same way no matter what the universe was made of. So those are some of the interesting things that I don't hear discussed. I hear lots of ad hominem attacks and, oh, they don't believe, oh, conspiracy this, oh, conspiracy that. And so we need to change that conversation to be, instead of this, where we're thinking about this in terms of the way that we're approaching these ideas, we need to think about them in terms of how can we actually do the tests, like the laser test, and they upgraded the optics and did all the other things, and they made a really serious attempt at what is a meaningful experiment to test their hypothesis. So I applaud them for that. And that's exactly the kind of thing that we ought to be doing to test the validity of some of the claims. But we should also be using and developing that into a model from which we can make a claim about, here's how things ought to behave if the Earth is this way. And so one of the other things that I thought...
The thing that bothers me most, right, is as somebody who has done experiments and things, right, when your data doesn't come out the way you expected it to from your hypothesis, right, you can't go cherry picking, right? You cannot,
right?
It breaks down first of all, there's ethical implications, right? I mean, in this case, it's really not that huge, right? You're just being a liar.
Absolutely.
But the whole, you're taking away any credence that you had in the development of these experiments, which are not flawed in their development, right? They were developed well. They are clearly, like, there was clearly thought put into, this is what I think is happening. I want to test this.
Right.
How do I isolate the variable of interest? How do I get a control?
Right.
They're clearly putting in the time to think about this. But the issue that I'm having is they're using the scientific method, and then when they get a result contrary to what their theory is, to what they believe their hypothesis should be,
right,
instead of taking that and retesting and running multiple trials, they are looking back and changing the experiment to get favorable results.
Fundamentally, the whole idea behind proposing a hypothesis, and I'm going to try and make that distinction between a hypothesis and a theory, because they are indeed different and we need to think about them differently, right? When you are testing a hypothesis, the scientific method is there trying to invalidate the hypothesis you're putting forward. You are trying to say, I'm controlling all the external variables, and I want to disprove the thing that I think is true, so that ultimately, by failing to disprove it, I provide some sort of support for my argument.
And it goes back to statistics, right? This is why statistics is structured in that way, right? You have a null hypothesis. This is the thing that I'm trying to disprove. You cannot use statistics to prove
anything. Right.
You cannot.
Fundamentally.
You can use statistics to disprove things.
Right.
That is how statistics work.
Yeah. Yeah. I wish that the news organizations actually had a sense of that, but clearly none of them have ever studied statistics.
I believe that they are watching, so news organizations hit us with a sponsorship. Come on.
Right? They could, so I should probably speak nice to them. Yeah, that'll probably not happen. But what I think will happen is we will get to talk about this idea of water sticking to a spinning ball, because they talk about, well, if the Earth is spinning at 1,000 miles an hour, then we would all fly off and all these things. Meanwhile, we would, if we were also on a rotating disk model, as some of the things have proposed, the rotating disk model would have the same proposition, or the same possibilities. Now, there are some other instances where that can be hugely problematic, but there are things that we need to think about there.
The rotating disk model, right, obviously would treat us all as if we were inside of a centrifuge.
Yeah.
Correct?
Yeah, that's one of the things that I've seen suggested. Most of the rest seem to be in the camp of the no, actually it's just this stationary disk, so it's like a frisbee that's frozen in time.
So the one that they cover in the documentary, right? I'm going to try to draw this, right? Because a lot of a lot of the people in the documentary believe that the Earth is, I'm going to have to turn off my, let me turn off my sweet background again.
The cubed Earth, that's really spectacular, however.
Right. They believe something like this, right? Here's my dome here. This is the Earth's surface, right?
Yeah. That's the Truman Show. The Truman Show. Right. That's what you're describing, is a large-scale version of the Truman Show.
This is, in fact, moving
which in space. I need to watch. I haven't even seen it. But yeah.
Moving upward, right?
Yes.
So this has a velocity upward, an acceleration upward, right? They're saying that it's accelerating. And that's an important distinction to make here. Because
the difference between accelerating and traveling, because that's the only way that you can account for gravity. So we're in this Earth ship,
right? So that's a vector
thing.
This is
yes, correct. That's an acceleration vector.
This is a vector. It's an acceleration vector. Right?
Yes.
So it's moving upward, right? And you know what the acceleration is? This is the thing. We are currently accelerating at either 32.2 feet per second squared.
Yeah.
Or 9.8 meters per second squared. And you know what happens because of that? We feel on Earth, right? And I realize this is drawn horribly to scale, right? I realize that.
Sure. Sure.
But the acceleration,
we're scientists, not artists, right? We aren't the artists that made up the Earth pictures from NASA.
We'll call it A sub R, right? Is downward by the same amount.
Right. Correct.
Now, the equation for relative acceleration is that the acceleration of any point, is equal to the acceleration of some known point plus the acceleration of that known point relative to the other point, right? That's now mathematically, I'm not sure that holds up, but that is the thought process, right?
Yes.
If I'm accelerating in a car, right? So if I'm in the car,
right,
and I'm accelerating forward, I'm getting pushed back into my seat, right? Well, it feels like I'm being pushed back in my seat. What's actually happening is that the car is accelerating into my back, right? That's what's really happening.
Right.
So as I accelerate forward, I feel like I'm getting pushed back, right? So if I'm accelerating upward, I'll get smushed down, right?
Right. Right.
Fair.
This is a balance of forces question.
Okay, fine. This sure. Okay, where?
It's at
But
least a plausible
it's the best. It's
response.
the best response that I've heard to um, the gravity theory or whatever the tenet that gravity does not exist. Right?
Right.
It's just
Right.
well, technically, if you're going to say gravity doesn't exist, well, you've just proven gravity.
Right.
Okay?
Right. Yes. That
The
model.
gravity does exist. It's just that it's a
Right.
balance and acceleration.
Right.
We're
It's a
in a
balance of
static.
forces
We're
there.
basically a dynamically equilibrious
Right.
system, right?
Meanwhile, others are saying no, it's not static, or it's static and it's not moving through space and it's not accelerating, and so we're not on the Earth terrarium ship
Right.
thing, right? And so, because there's some that have gone to extremes and gone, oh no, this is the, you know, the Earth is on pillars because that's what it says in Scripture, the pillars of the Earth and the things. And so, how dare you put the curved Earth on
Sorry,
your background? We're talking about the flat Earth here, the cubed
didn't mean to
Earth.
be
I think the cubed Earth
disrespectful.
would actually
The
make
cube Earth
more
would solve a lot of issues, right? I would.
solve some of their problems
It
with their
would.
models. But yeah, you want to delve deeper into that before I get into the brainwashing part?
What
Because we are
the cubed
brainwashed.
Earth?
You realize that, right? The brainwashing.
I have, and there was part of the documentary that I watched earlier today, in which that I thought was pretty comical. They were
Right.
at NASA in Houston,
Yeah.
right?
Yeah.
And well, this goes to the brainwashing. We can save this for a minute. But the cube Earth, right? The cube Earth. I would I would buy this theory most out of all, personally.
Yeah.
You can see it behind me here, right? Well, I can
Right.
right.
Yeah. Then I'll
You
start
can't
picking up
see that, right?
the hand railing and some of the other things. Yeah.
Yeah. All right. So essentially, it's just that the Earth is a cube, right? Okay. Right. Does it behave the same way? Is it still rotating? If you told me that the Earth was a cube, right?
Mm-hmm.
Okay, I would. That's right. But
Bizarre, but
it still
all right.
spins on an axis and everything.
Right.
Right. Right. Well, right. Obviously, the issue comes. Well, what happens when you get to the edge, right?
Yeah.
How do you traverse from? But the idea of gravity makes that fine, right? You would stay on the surface of the Earth
Right.
because there's gravity, and it's
Right.
just a cube instead of a sphere.
Right.
I would believe that. I would believe any three-dimensional shape that you decided like would be a good substitute for a sphere.
Right.
And I
A
think this is the problem for
dodecahedron or
me,
some
right?
other, like, there's
Even if you
lots of
wanted to go
choices.
simple, right? If you wanted to go simple and just make it a pyramid, right?
Right.
Right? It's four sides, one's flat on the bottom, right?
Yeah.
Australia's on the bottom face.
Right. And that's
Okay,
always facing the sun, and that's why it's so hot there. I mean, it makes
right,
sense, right?
right. I mean, so I so I think it's pretty obvious, right? I do not subscribe to this theory that the or this hypothesis that the Earth is flat, right?
Yeah.
I personally, my personal opinion is that the Earth is a sphere. Now I realize that means that I've been brainwashed, right? And
Yeah. Yes.
I've drank Kool-Aid
You've
and all these things. And
right.
you know what? It tracks with because I have a PhD, that makes sense, right? Because why would I
Right.
want to admit that
You've
everything that
you've
I've
had
built my education on is a lie?
not just the Kool-Aid. You've had every flavor offered.
I am
Right.
essentially right. I am being paid off by the government right now to
That's right.
propagate this.
That's right. See, that's the
That's
thing that's
that's
so
what's happening.
interesting. There you go. Because what really it is, and that's why scientists drive nice cars, right? It's all the government
Right.
money to keep it all hush hush,
I have a
right?
sweet Ferrari sitting in my
Um,
driveway, right?
so that's that, but it's in the driveway of your underground CIA bunker,
Hmm.
which that's, I can't even keep a straight face because the idea that you would have tens of thousands of people all holding up the carefully orchestrated construct by a master planner behind the scenes, the super rich, I think, are one of the ones that are often to blame, like the Bilderbergs and some of the other stuff.
Well, the amount of coordination to propagate this is astounding. Humankind has never worked this well together ever. Ever in its
In the
history.
history of mankind.
In the history of humans.
I
Okay?
would love to see them get 1,000 scientists in the room and get them to agree on something like even just acknowledge the existence of dark matter or something. Like even that, even just not agree on all of the models, agree on all the geometries and all the physics, just 1,000 scientists from different fields and get them to all agree about dark matter's existence in the first place, because it's a thing that we can't scientifically measure, and so it has to be there because we know that there's effects of stuff that we can't account for, and so there's stuff missing in the universe, and so science is grappling with all kinds of problems. That's why nobody from the science community is actually taking the flat earth discussion really seriously. That's why people like Neil deGrasse Tyson is dropping mics, and that proves the earth is a globe. No, that does not follow. That's non sequitur, but entertaining, yes.
But to the point, right? To that point, and I think this is a very important thing that we need to. And we brought it up earlier, right? In the earlier at the beginning of the show, right?
Mm-hmm.
We gain nothing as a humankind, right? As a community of people, from discounting everything and calling people names and making them feel marginalized, right? That is something that has been proven throughout history. And so the point of this is not to do that. The point of this is to open discussion, right? I would love it if somebody was like, hey, do you want to be part of this experiment? And sure, I would. It's the same as working in an interdisciplinary team, right?
Sure.
I don't necessarily have the same beliefs as you, but we can work together to do some science.
The analysis of the data is the thing that we enjoy in particular, and that's why we like to do stuff, and that's why we're working hard to figure out how to still kind of do hands-on learning things only through the internet, because everyone's gone absolutely nuts about this virus thing. And so, yes, there are very real effects. We've already addressed in the other podcast the difference between
this is where we plug episode 1,
mass hysteria.
Go back and watch episode 1,
and some of the things that you can actually do and have them be meaningful, and kind of where some of those distinctions are. So there's a lot of things that are important here, and I think one of the other ones is to really hit on this point, particularly for us, because we're in this weird category of being Christian scientists, not to be confused with like the Mary Baker Eddy kind, because that's not, like, that should not be a thing. That should be abolished as heresy or something even more ridiculous. But Christian scientists are the people that literally everyone loves to hate on. So go ahead and hit this video in the comments and tell us what kind of stupid morons we are, because that's obviously what I can hear you typing through the internet, all the keyboard warriors. But I'm curious to hear some of the thoughts and particularly some of the questions, because we're trying to have an actual dialogue about this instead of just flame war, right? We're not trying to set a dumpster fire, because there's far too many of those, but we want to actually hear some of the feedback. In the context of being Christian scientists, this idea that, well, people that believe especially people that have gone through this process and gone through the PhD trial by fire and all those things, you just believe in scientism. No, actually, I don't. I believe that in fact a very different approach has to be taken, where science cannot explain all of everything. Science is very helpful and it's very beneficial. We learn lots of useful principles and properties, but science doesn't explain. It explains things like, well, the universe had to have started from an immense force at the beginning of time. right?
Mm-hmm.
And so the scientists, especially the atheist, naturalist perspective, would tell you they don't need a creator or an all-powerful being there. They just need gravity as the thing that was the nearly immeasurable force that started everything, right? As a Christian, I would say it actually seems to make a lot more sense that this immeasurable force actually guided things into being the way that they are for a specific purpose. But that's a line of distinction where belief enters on either side of the line, right? And so only people who are intellectually dishonest or have not thought their way through things will say that I know for a fact that such and so, and this is how the universe started. No, we don't. We know that there was an immeasurable, nearly incalculable force that started things, but that's not the end of the discussion. So that's something that's very, very different from us. Is scientism is not a thing. I understand the concept of worldviews, and I understand that from taking a flat Earth perspective, a flat Earth worldview makes everything look conspiratorial because there are groups conspiring to cause us to think all sorts of things. And so I'm sure there's no end of the rumor mill for what's happening right now, because we have some very different things that we're seeing in terms of numbers and results from the situations going on right now with our global virus pandemic happening. And I think some people made some really unfortunate choices in trusting on the face value some data from the Chinese about this, because the Chinese don't really have a super great track record of intellectual honesty in their research. And in fact, I just saw a publication that, and I don't even think I've shared this with you yet. I just saw a publication that went through and studied the funding of universities and where the money comes from. And they found that even ASU, where you and I both went, were literally the first thing listed in their particular study that has taken lots of money to the tune of many millions of dollars of funding that they didn't disclose to the government, that involved this whole project that a bunch of foreign governments have invested in these universities to get them to change curriculum and include things that are favorable. And one of those nations was China, to try and cast their country in a little bit better light, you see. And I happen to be the victim of some of that kind of very well-funded research that was not done with scientific integrity. And so people fabricated data and did some other things, and nobody cares. And the people that are guilty of these things are untouchable because they brought in untold millions, probably through that exact program. So the fact that they happen to have very significant ties with China and some of these other things is beside the point, because that could all be coincidental, but the math there would add up 1-to-1. So the fact of the matter is, the institutions, the higher learning institutions, are compromised. There are research ideas being stolen, and that's the whole purpose of this, is to change the curriculum and to basically get research directly from the institutions and steal it so that it can be taken back to China, turned around and published from some of their institutions. And so they literally fake and forge and buy their way into the forefront of science to try and stay current in all sorts of other things. So I'll share that article with you, because it's actually really interesting. But this kind of thing is causing all sorts of legitimate challenges to the integrity of the scientific field as a whole. And so that lends credibility to the people like the flat earthers that are going, y'all are being lied to. You're out of your minds. You're brainwashed. Well, you are being lied to a degree, and it kind of varies by institution. But this is part of the reason why we focus specifically for our students so heavily on critical thinking, being able to think your way out of a wet paper bag by the time you leave our classes. That's why this stuff is important.
I suggest brute force, by the way.
Right. Beat it into them with sticks. I'm sure a few of them will see
this
and resent it.
It's wet. Just
yeah. I mean, yeah,
pick a direction and run.
Right? Yeah, just go faster. So anyway, there's a couple more points that I think I wanted to touch on, and then we should probably wrap up the stream. And I don't think we'll get to some of the actual scriptural stuff because that's there's so much. Oh my gosh. So that'll be a separate video, I think, to actually address some of the scriptural side of things, because that's a whole different ball of wax, because there's a bunch of Christians that are like, oh, the Bible's a flat earth book and you just need to read it. And right, so I did, and I'll have to bring you guys up to speed on the findings, but it's
such a long book. I mean,
it is such a long book, and there are when they say there's hundreds of references, they're not kidding.
No.
But there's not hundreds of references to the Earth being a globe or a soccer ball or things like that. But there's some reasons for some of those. So one of the other things that's really, really important, and I would love to show some of the data, because I'm now running on some solar panels, and I would love to show the data that actually speaks to this directly. But the idea is the Earth is closer to the sun in winter. This is one of the problems they have with this globe model. And so if the Earth is closer to the sun, then why aren't things hotter? Why is it colder in the winter if the Earth is physically, that hemisphere is closer to the sun because of the angle and precession? If everything was really tilted on an axis like it's claimed in this model, right? Why is the Earth cooler when we're physically closer to the sun? How does that work, right? And so, have you actually encountered that one at all?
I have not, but I'm thinking, so depending on this is the thing that's tricky with this, right? Depending on who you talk to, you might get a different opinion or belief about what constitutes the flat Earth, right? Some people think that it's domed, right? And like that first model that you showed on that one picture that has the rotating sun and moon inside of the dome, right?
Yeah.
That model doesn't allow for season changes, right? It doesn't. It's just the sun and the moon are always in the same spot. They just rotate around in a 24-hour cycle, right? So 12 hours on, 12 hours off.
Yeah.
Okay? You've got people who think that there's the infinite plane, the stationary in space people, right? All of these have their own individual and unique issues that I see with them, right? Now, again, flat earthers prove me wrong, right? Let's talk about
Let's actually have a dialogue. Yeah.
Right. I mean, I'm just a dirty globist, right? So it's
right.
This is how it is.
Filthy elitist, globist, CIA, brainwashed. Yeah. Right.
Once you're done with the names, we can talk about it.
Right. Once. Let's get to the actual substance.
I've been called worse before.
Right. So this is one of the examples that I wanted to speak to, because I don't have my account set up, and I'd have to log in and all the other stuff, because I just haven't logged in physically on this computer, because I'm too busy like doing my day job and teaching students and all that stuff that I'm actually paid to do, instead of this stuff which we're doing out of the goodness of our hearts, and also because it's maybe marginally more beneficial to society than playing video games or other things we could be doing.
This is how you have social interaction now,
right,
in the COVID-19 world.
It is. So this is an example of solar panel production during the course of the day, right? So what's happening is the sun has an arc across the sky, right? There's all sorts of issues that people are going to take because the globe, it doesn't actually arc over the earth, it just spins around and around, right? So we'll ignore the fact that it actually still goes over the horizon, and we'll pretend like that makes sense for a flat Earth example,
Sure.
instead of just sort of going away and getting smaller and smaller and smaller at the same altitude in the sky and then disappearing because it's too far away at the same altitude because everything is flat, right? And so we wouldn't observe any curvature in the path of the sun because it would circle around us, but it wouldn't change in elevation
Hmm.
because of the way the models are presented, right? So
Hmm.
that's
Right.
the trajectory of the sun is still hugely problematic in this, hugely problematic. But what it does is somewhere around 7 or so a.m., you start to get that, especially if you have mountainous region or something, you start to get that solar output starting to pick up because the sun goes through this parabolic path, and that's literally what you see graphed is the amount of light reaches a peak right around noon, and then goes down over the course of summer. And for winter, it's narrower because we're closer to the sun. But the important thing to pay attention to is that in the winter, the whole graph is shifted down lower in the energy band, because what's happening is you can see the effect of the angle. When the sun just comes up, it's at a steeper angle. And so that angle, you get a cosine roll off of the power production that's happening on the solar panel. So let's talk about this idea of the experiments, right? We're doing actual experiments every day on my roof about the change in angle of the sun and the intensity of the sunlight that you get as a result of that. Those things are measurable and repeatable, and therefore those are science, right? Those are things that we can go back to again and again and
Hmm.
again and again. Happens the exact same way every day. The differences are things like how many clouds come through, or did a bird decide to have an accident on one of the panels or something, right? Some of those are the things that change things. But the point is that cosine roll off happens because of the change in the angle of the panel with respect to the sun. So when the sun is at a different angle, i.e., when we're at a steeper angle in the winter than we're in a more oblique angle in the summer. The actual insolation, the amount of sunlight that we get, spelled differently than insolation with a U, insolation with an O, that difference in angle is actually what's achieving the results of changing the power levels on those panels, just like they are in the summer. So at the summer, we're in more of an oblique angle to the sun, and so we get a little more concentrated insolation. When we're in the winter, that change in the axis is the very thing that keeps us from burning up in the winter. Because if the Earth wasn't at an angle in the way that it is, exactly the way that it is, we would have unbearably hot winters and we wouldn't have seasons. Everything everywhere on Earth would be like Phoenix, low and high, right? We don't really get 4 seasons. We get low and high. It's like a crock pot. It's really bad.
Hmm.
But the point is, those changes in the angles of the sun with respect to the curvature of the Earth, those angles work in exactly the same way as the change of angles as the sun goes through its path for solar panels. It's the exact same principle. It's all about how much area is that distributed over, that same amount of energy. Because the
Hmm.
distance from the sun is closer, so there's more energy available, but by tilting it at a steeper angle, that's the same principle for ballistics and armor and energy distribution. It's all about distributing energy, right? And you spent
Hmm.
some time in that particular industry,
Yes.
so you have some sort of an idea about ballistics and how energy is really important.
Yeah. It's that ballistics stuff, and I did some a little bit of accident reconstruction, right?
Mm-hmm.
So understanding energy distribution is
Energy
something
distribution.
that is
That's a thing.
um,
That's a thing you've
relative
studied.
to,
It's
yeah.
not a thing that you were programmed and brainwashed to
No,
understand.
no, it's relative to a lot of everyday systems,
Yeah.
right? And specifically has impacts on how we can analyze injury, right?
Yeah.
And so going into the ballistics portion of this, what is the reason that if you shot a bullet straight up in the air, it would not hit you um, in the head when it came back down? Why doesn't it land straight back down?
Right. Right. One of the first things to think about there is the idea of the frame of reference, and that's a thing that's also not that's regarded as like mathematical trickery or mathemagic or all sorts of other things.
Well, look, if I don't like my answer, I'll just change the frame, right? That's not how that
That's
works, right?
not how
Frame
that
of
works.
reference doesn't change your answer; it just changes where you're
Right.
viewing the answer.
You hop on the back of my pickup truck. I'll flip
Mhm.
the bed cover up. You, the theoretical flat Earth person that's watching, you will accelerate to freeway speed at 65 miles an hour. Except here, really, a lot of the people mostly go 80 because why would you only do 65?
Because it's the Wild West.
It is the Wild West, right? Everybody's armed, and now they're armed lunatics who can't get groceries or toilet paper, and so now they're 10 times more dangerous. So you really don't want to fall out of the truck bed. The thing is, if you jump while you're in a truck bed and you're moving, and I think there have been some Mythbusters episodes. So for the next show, I'm going to see if I can find some of those clips to be able to incorporate, because that would be great. But the thing is, if you're passing a ball, because I think they did this where they played like a game of catch or something between a couple truck beds, or they did something where they were testing this idea of the frame of reference, and they
I have a
found
really
out
good video
that it's
actually.
yeah. It's so that's a thing that's really really important, because if you jump up and down, you don't jump up and suddenly you're left like a cartoon and the truck is gone and you fall to the ground and break all your limbs and roll at 60 miles an hour until you stop. That's not how it happens. You have the momentum of the truck as well, and so this idea of conservation of momentum is not taken seriously on the part of a lot of the flat earth folks, and that's another thing that we really need to hit on. So that frame of reference thing is really 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 important, because you can play catch in the back of a moving pickup truck. It may not be a good idea. Now if you throw the ball up and it gets caught by the wind resistance and taken out, that's a different thing, because you are adding wind resistance into this problem. And so yes, if you jump completely over the cab of the truck and you manage to somehow have a 10-foot vertical, which I sort of doubt, I think that's slightly unreasonable. If you were to get that high, then yes, you would start to have some of the effects of wind resistance carrying you backward in the truck. But the point is, you wouldn't just jump up and stay in the same stationary position relative to the earth. You're going to move relative to the earth because of the momentum of the truck. This is how the math works. This is also how the experiment works. So yeah, try to jump up in the back of a moving pickup truck. That's not really great advice if you want to live a long, healthy life, because you can hurt yourself doing dumb things in the back of pickup trucks. But a lot of people have survived worse. So
It's true.
yeah. All right. Any final closing thoughts so that we can wrap this one up? I think clearly there's at least one more of these that needs to happen, at least.
I think so. I think we're gonna have to do another episode to just kind of tie this all together. I no, I just want to reiterate, right? Like, if you have strong opinions on this either way, that's great. Okay, we're not saying anybody's right or anybody's wrong. My personal opinion, my personal belief on this is that the world is a globe, right? Earth is a globe. That is
Right.
my personal belief. I am not trying to say that you are less of a person. I'm not trying to say that you are inferior to me in any way, right?
Right.
But I want to have a discussion about this, right? I want to hear what you guys have to say. I don't want to just hear the documentary version or read, Bob's page on
Right.
flat Earth, right? Like, I
Right.
want to hear this from. I want to talk to
I
people who are
found a
in it.
flat Earth's fact page, and there's supposed to be like 200 proofs or something, and it was clear that the person that summarized that couldn't do math, because it was like 1 through like 13, and then it jumped to like 65, and then all the way up through like 85, and then it jumped to like 134 or 132 or something, and then to 148, and then that was it. And
Sure,
so
sure.
I maybe the so maybe they learned counting from Microsoft. So maybe Bill Gates is behind the whole thing.
Oh no, why you say
Maybe
that?
that's what we can investigate in the next one.
Oh my gosh,
All right.
we're gonna be in so much trouble. They're gonna shut down the whole internet.
Right. They could. As next I'm gonna be DDoSed. You watch.
Next time,
Right.
10 things that they don't want you to know.
Right. Right. 10 things the flat earthers don't want you to know. Oh
Bill
boy.
Gates doesn't want you to know about flat Earth.
Right. Yeah. It's yeah, because that's because he's too busy giving everybody the virus, which somehow he developed and released or something is the next thing going around. Yes. I don't even know. It's 100%. Hard to keep up with.
All right.
All right. Well, I think we should end it there.
I think that's a good spot. Next time we will, we'll tie this up next week. Please come back. Please feel free to comment on this. Pass it around if you want.
Yeah, follow up and let's have an actual conversation. Honest conversation. So I think that'll be interesting. And I think with that, we'll see you all in the next one.